Hello everyone, welcome to my talk. My phone runs Debian, it does phone calls. This is for DebConf, a somewhat unusual setting, but I'm very happy that DebConf is still possible actually. Thanks a lot to the DebConf team for making this possible. So about myself, since not everybody might know me, I'm a Debian developer since some time. Besides the phone-related packages I'm going to talk about, and which are rather new in Debian, I've been working on libvirt and related packaging and Git build package mostly during the last years. And as a spoiler, I'm working with Purism on the Librem 5 phone, and this is the device I'm using, so I'll talk about that device quite a bit since its design goals influence the software stack I'm running. But no worries, this is not going to be a marketing talk by any means. I had used Debian on the OpenMoko before, and Memi on which is also Debian based, on Nokia's N900. So before switching to the Librem 5 recently, I've used Debian-based distributions on my phones as well, and I'm really looking forward to see Debian running on recent devices. So as an overview of what to expect from this talk, I'm first going to talk about how the mobile stack I'm running looks like and why it looks like that, what of that is in Debian already, and what it's still left to do to make it run smoothly and to work on more devices. Since we can't have an on-stage demo, here's a screenshot of the calls application, which is surprisingly also called calls. As an introduction, let's go back several DebConf. So at DebConf 17, I attended Debugger's BOF, which was called Pushing Forward Debian on Mobile. You find the link to this and other stuff at the very end of this slide set. There was quite some discussion going on how to get Debian onto mobile devices. The room was pretty crowded with 50 plus people, and lots of ideas ranging from using the OpenMoko stack to get something going up to building a Debian user space on Android devices were tossed around. Also, there was some talk about why we want mobile devices to run Debian, except for that we want everything to run Debian, like software freedom, proper security updates, and user instead of vendor control. So basically all things we take for granted on our laptops and maybe our servers and workstations, but we don't have that on the mobile devices we carry around all day. So what are the actual obstacles to get Debian running on mobile devices like smartphones? The obstacles on the device side are lack of hardware support for current devices. So chip documentation is often very scarce and makes writing functional drivers very difficult. Although Postmarket OS did a very great job here to get Linux boot on more devices. And maybe except for the Pixel phones, you're very often locked out of your device and have to root it in order to install another operating system. So vendors make it pretty hard for you to run something else than what they shipped. There's usually proprietary user space bits, very prominently the OpenGL and Vulkan drivers, which are usually needed for fast and energy efficient rendering. Devices run heavily forked Android kernels with non-mainline interfaces and tons of vendor drivers of very different quality. User space looks pretty much different from what we are used on our laptops and servers, using a Bionic libc, Surface Flinger, and these kind of things. So not very easy to get Debian going as a start. And on the Debian side, one of the issues is that we are lacking adaptable user interfaces and apps that properly work on small screen sizes and adjust to the small screen sizes. A key takeaway from that BOF for me was that having a few devices that are affordable and current, like the OpenMoko was like many years ago, would give us a very good start for developers to hack on it. A couple of weeks later, Purism announced the crowdfunding campaign for a Linux-based smartphone named Librem 5, named after its 5-inch screen size. Many things identified as problematic in the DebConf BOF looked as if they could just be ticked off with this device. Like the SoC using a Vivante GPU, so we could use the existing, already reverse-engineered Ednaviv driver to avoid user space OpenGL blobs, or that the device should be running a mainline Linux kernel. So I went ahead and backed the campaign. Again, a couple of weeks later, it was near the end of 2017 already, through some very lucky circumstances, I found myself actually working on Peterson's teams that would build the Librem 5. Besides many more things the Librem 5 campaign announced, there was one additional campaign goal, convergence, which will be important later. That means that users should be able to run the same applications on the phone as on their laptops, but it also means that one should be able to connect an external screen and keyboard to turn the phone into a workstation. Since Peterson's laptops run the GNOME desktop environment by default, the mission statement for the software side of the Librem 5 could be summarized like, let's build a modern smartphone running a pure Wayland GNOME-based software stack with a mainline Linux kernel, a Debian-based operating system, and no binary blobs that user space needs to mess with. Now, how hard can that be? Well, quite hard as it turned out. So there were some obstacles to overcome. So first of all, since this was a completely new design, the hardware wasn't designed yet. The SoC, so the main chip used in the phone, an iMix8 from NXP, had no Linux mainline support yet. Even the EVK, so basically the reference board that demos the chip's capabilities, wasn't even publicly available at that point when we started. And GNOME was not suitable for mobile devices and small screen sizes as is. But GNOME had some mobile background, since some of the hidden parts of the N900 went into GTK3, so it is already touch-aware, for example, and it has great integration into Debian, making new releases very easy to integrate. So to start off with software development, we used boards with earlier SoCs from NXP as a stopgap until iMix8 boards became available, and thankfully Debian was already there as a base to build on. I leave out all the hardware-related bits from here on. For details, please check Nicole's CCC Camp talk, a mobile phone that respects user freedom, which I can only recommend watching. But for the software side, if we wanted to have something workable soon, it was clear that we didn't want to reinvent the wheel, but use as many existing parts as possible. This should also help long-term maintainability, but only time will tell. So that's what we came up with. Let's start with the apps. Apps remain regular GNOME apps. Of course, there was no point and no way to rewrite existing applications, like a calendar using a mobile framework from scratch. Also, having is mobile scattered all over existing code bases is out of the question if this should ever go upstream. But only if the code can live upstream, actually, then developers and designers can care about size constraints and mobile patterns, so we can get a consistent design and well-working apps for desktop and mobile. See the convergence argument above. So Lipandy was born. This is spearheaded by Adria and Alexander. Lipandy is a widget set to support adaptive apps and mobile patterns written in GTK. It's regular GTK widgets that just do the right thing according to the window size. So they hide content when the window is small and show more content when the window is bigger. It also cares about touch-based mobile input patterns. The size thing makes it not only useful on mobile, but also on desktop to show relevant content on different window sizes. Lipandy moved to GNOME infrastructure recently and is being used by quite some GNOME apps already, like GNOME Control Center, Epiphany, GNOME Usage, Geary, and GNOME Clocks, for example. These will mostly come into Debian with GNOME 3.38, which is already shaping up in experimental, but there's more to come with GNOME 3.40. Some bits are in Debian already, and I tried to demo that a little bit. So this demos the adaptive header bar. So you have the header bar here, and if I just start the demo, you see how it adapts to the size constraints. So it first moves the text below the icons, and if things get even smaller, then it moves to the bottom, so the header bar stays free for the menu and other things. And as the app grows in size, the space is being used again. The other thing is the leaflet. This is like with GNOME Control Center. You see that when the window gets smaller, then the selection area is being hidden and only the content area is being shown. Then you can go back, select the tab, and then make the window wider, and it will use the space again. So for the session side, the applications are running in an almost like regular GNOME session, with GNOME session itself being responsible for maintaining the session. GNOME settings daemon, as on the desktop, is responsible for brightness control, power management, etc. There are the usual, so to say, lower layers with policy kit, uPower for battery monitoring, udisks, network manager to handle Wi-Fi and mobile data connections, and modem manager to handle modem integration, SMS, and voice calls on these things. There's one additional component named feedback-D, responsible for haptic and LED feedback, depending on the user's loudness settings, so to say. It's somewhat modeled like the sound event system, so when an app received an email, the app just tells feedback-D to provide feedback for message new email, and feedback-D would, for example, blink a LED or whatever is configured in the current feedback theme. It's a new component since desktops usually don't need to worry about this, but it will be useful on tablets, for example, too. The major difference is that there's no GNOME shell running, but Phosh, which is like short for GNOME shell, plus some other components. So why is that? Why not just like use GNOME shell? We wanted to build a pure Wayland shell since we couldn't imagine doing the work twice, like for Wayland and for X11. Also, we wanted to investigate a separation between the compositor, the keyboard, and the graphical shell. Ideally, we wanted to use the same toolkit for shell and application development, so we can, for example, just use lib-handy widgets to have the same patterns we'd use for the shell and for the desktop. Otherwise, we kind of like have two toolkits, one for shell development, one for application development. And we kind of like discussed all this with the GNOME developers, and when one core developer said, please don't try to shrink the shell, it was basically set. But again, we didn't want to reinvent the wheel. So this is what we came up with. It's basically three components. So Phosh, the shell, Fog, the compositor, and Squeakboard, the on-screen keyboard. So Phosh is the graphical shell that handles all the dbus interaction and talking to dbus daemons. It also has the user interaction, sort of the bottom bar and the overview for launching available apps, the quick settings, and all these kind of things. The compositor handles graphics output and touch, mouse, and keyboard input handling while talking basically the Wayland protocol to the applications. This is comparable to other Wayland compositors like Quinn or Sway. One difference is that by default it just like maximizes all applications, since they should usually fill the whole screen on mobile. That can be turned off when running in desktop mode. Maybe also noteworthy, it can downscale apps that don't fit the screen. So this can be turned on per application. So if, for example, like the Firefox window is like a tiny bit too wide, you can kind of like make it shrink down so it fits on the phone screen. That obviously has its limits when UI elements get too small, but it can be a usable workaround to get an application going right now. As for the shell, as we wanted it to be, it uses the same toolkit as the desktop applications, so it's written in GTK and uses libhandy for the adaptiveness, and hence we can use the same debugging and programming techniques that we use for the regular applications. For shell-like behavior, it uses a protocol called layer shell, which was invented by the WRoots guys. WRoots is the compositor library here at the very bottom that is used by Fog to build up the compositor, and Squeakboard is the on-screen keyboard, basically converting touch presses on the on-screen keyboard into key presses seen by an application. This allows the three components to evolve independently, and only a compositor crash takes the session down. All other components are restartable. Here's the screenshot from an actual device. So on the very left, you see the application launcher with some favorites over here and all the other apps below that. You see a running application like here, and this is the quick settings. So you have quick access to the Wi-Fi settings. It also has some more details like the Wi-Fi network and all these kind of things. It's quick access to the music player, and on the right side you see a running application, which is in this case the terminal, and see the on-screen keyboard for the input. Finally, at the bottom of the stack are the Linux kernel, U-boot, and ARM-trusted firmware. On top of this sits a regular glibc, so we don't have to worry about like Bionic libc or Halium as on Android or similar things. As already noted, the kernel is like a major issue with most modern phones, since they usually build off a heavily forked Android kernel or board support package. So is it actually possible to have a device booting plain Debian in, say, Bullseye or Bullseye Plus One and being actually usable? We'll see that in a moment. Now, what is left to do? First of all, you might have noticed that I've not talked at all about the actual applications doing the phone calls or the SMS handling. That's mostly due to time constraints of this talk. So calls and chatty, how they are named, are doing their job pretty well, but there's certainly also lots of things that could be added, for example, MMS support or similar things. What we also obviously need in the stack is lots of polishing. So we want to improve gesture support in the shell, and we want to avoid some flickering when hiding and unhiding the on-screen keyboard. We need to improve on X-Wayland support for convergence, so X11 apps have a chance of working as well as Wayland apps do. And we need to figure out desktop versus mobile. So currently, if you install an application, it puts a desktop file there, and it will be always in your menu, independent of the screen size and if the application can actually fit the screen or not. So if you install, for example, KiCad, it will never fit the phone screen. You can scale it down, but then it will become pretty much unusable. So you usually want to hide it by default in a mobile setting, but once you connect an external monitor, you want to see it in the menu and start it as usual. That's something where we have to come up with an extension to the desktop files or something similar. But I think we have enough in place to go bug by bug now. So as a summary, overall we're pretty close to the regular GNOME Linux system. This allows us to use the patterns known there and inherit the stability of the stack. The above is supposed to work on mobile and desktop, currently focusing on mobile. The idea is to extend existing programs and services when available, rather than rewriting from scratch. So what is the state in Debian? So while Lipendy and double roots libraries were in Debian since some time, the whole packaging effort got a major boost when the Mobian project started. I'll explain some more what Mobian is in a couple of minutes. Since then, many parts of the stack went into testing and unstable. Some more are sitting in U. So we have Lipendy, we have Phosh, we have Fork the compositor, we have double roots, we have feedbackd. And many thanks to Arno, Henri Nicolas, and Evangelos for this. Most notably missing at the moment is the on-screen keyboard, which is currently blocking on the Rust dependency, and also the calls and SMS applications are currently in new and need to be processed. GNOME 3.38 will bring in more adaptive application, and the GNOME team is currently preparing that in experimental, which is totally great. So what is left to do? We have some apps that have non-mainlineable patches because they basically make the app fit a small screen but break some behavior on a large screen. And we have some GDKs patches which we need to worry about. They improve working on mobile, like making the file chooser adaptive or making the about dialog adaptive, but they also break the desktop use case. That is not so much of a problem at the moment for mobile-focused downstreams of Debian, but of course it is a problem for Debian itself that need to be fixed. The path here actually at the moment is kind of like to try to mainline what is mainlineable into GTK3, which is pretty much frozen, fix things for GTK4, and make the rest toggleable, and then check with the GNOME team at some point if that is workable for Debian. Also, as a to-do, we obviously need a functional kernel, U-boot, and ARM-trusted firmware. So is this realistic? I pulled out some of the Librem 5 numbers to see where the whole thing is going and if it's possible to have like a mainline kernel that is supportable by Debian in Bullseye or Bullseye +1. So in the table above, I've looked at the kernel sources and the diff from the Librem 5 kernel to the mainline kernel, and I've excluded changes to board configurations, device tree, and include directories. For one, to make the diffing a little bit simpler, and since if the device drivers itself are in, basically the includes are just something that goes along with them. So when we started to look into the IMX8 support, that was in mid-2018, and the next kernel release would be 4.18. So we took about 100k lines of patches from NXP's older board support package. So basically the code that they ship in their evaluation kit, and upgraded it to current kernel interfaces and added support for our device. The result was actually like a real Franken kernel, and the delta was like just frightening. We then just started to cut out things we don't necessarily need at the moment, so like the video acceleration or the camera support, and rebased the patches on patches posted by Lukas Stach for initial IMX mainline support, and also started to rework things to a mainlineable form, and also started submitting first bits upstream, and thankfully we weren't the only ones, but there were more people working on IMX8 upstream support, and so the delta shrunk quite a bit with 5.3, so there were only like 38,000 lines of diff left between like the Librem 5 kernel tree and the mainline kernel tree. With 5.7, this reduced even further, especially the number of files changed, which is kind of like an indicator how many device drivers need fixes, reduced quite a lot, and we there went down to about 35,000 lines of code to the mainline kernel. That still looks like a lot. So I broke down the numbers a little bit more, and of the 35,000 lines, 20,000 lines of code are the Wi-Fi driver, and this one thankfully has a replacement in the mainline Linux kernel already. Unfortunately, there's some bugs with Mac randomization, so we're not switching to the mainline driver just yet, but soonish we can just drop the whole 20,000 lines of that driver and use the mainline one. The DCSS, which is one of the display controllers in the Librem 5, the one we're using to drive external displays, not for the internal one, is very close to being merged. This is work done by NXP itself. The MHDP driver is basically the DisplayPort output side of that thing, and there were also patches posted to the kernel list, but they need some more work because they need some more work before they can be applied. The rest on this list, like the Librem 5's LCD panel driver or the DSI host controller, are either already part of 5.8 or will be part of 5.10. So once this is out of the way, this leaves us with about like 2,000 lines of code as a delta to the mainline kernel, which is not that much by kernel standards. The Librem 5 device tree is also part of Linux Next already. This will see further patches to enable more hardware in the upcoming releases. So while this will likely not work out of the box in Bullseye, it looks doable in the bookworm cycle, so we're not too far off. We've upstreamed about like 125 patches so far, which I don't think is not that bad. A bigger to do is U-boot and ATF. We have patches for mainline U-boot, which we need to feed upstream. This is mostly board support, and so I don't hope that there's like much controversy. With ATF, it's a little bit different. NXP is using an older branch there for some power management features, and that will require some more work to forward upstream and to get integrated. But it still looks pretty much doable. So further to-dos on the Debian side is we obviously need some official installer and image generation. We need way better out-of-the-box support, so per device UDEF rules that make sure devices suspend quickly to save the maximum amount of power. We need some mobile tweaks packaged, like using a mobile browser agent by default, using faster screen blank and these kind of things. This will be parts of this will be part of the next Phosh release. And we need a meta package and task to pull in all the necessary components. I've prepared something for that on Salsa already, but there's currently some naming discussion going on. But once that is in, installing a default set of packages will become much simpler. So, but what if you want to run a distribution very close to Debian right now? There's Mobian. Mobian is the Debian derivative that aims to make mobile Debian possible right now. It currently builds images for the PinePhone, and it also wants to support the Librem 5 later on. The project is and was also a primary driver in getting the GNOME Phosh-based stack I described above into Debian, as it runs that by default. For more details on Mobian, see Arnaud's talk from this year's online mini DebConf. There's a link at the end of the slides. And then there's PureOS, of course, developed by Purism, where large parts of the stack I described above are currently being developed upstream. We build images for the Librem 5, but there's also people running these on the PinePhone by swapping out U-boot and kernel. And of course, there's also not Debian-based phone distributions, like Postmarket OS, which are worth to check out too. So how to help? You can help packaging other mobile stacks. There's UbiPorts, there's Plasma Mobile, and more that could be in Debian. You can join Debian on Mobile. That's a Salsa group that gathers mobile-related packages. If they don't fit into language-specific groups like the Python group or the Rust group, then they go there, but all the rest we kind of like gather at Debian on Mobile at the moment. You can join the Mobian project or PureOS. You can help making more apps adaptive, one app at a time. So lots of them are around that already have patches that need to clean up and move upstream, and there's others that still want to be patched. Or you can just package more apps. So if you join the PureOS or the Mobian channels, you see new apps announcements, which would be great to have in Debian. So to sum up, at least from my perspective, Debian on mobile devices is becoming a thing in Debian, and it's becoming suitable for everyday usage. Here's the links I talked about. Here's a link to the slides. And if you want to provide feedback, then just mail me or reach me on the Fediverse at agx@librem.one or reach out on OFTC. Thank you very much for your attention, and I'm happy to take any questions.
Thank you, Guido, for the talk. So we have quite a few questions on the Etherpad. So let's begin. Guido? Okay, let's start. So let's start with the first question, which says, which hardware does it run on? So it says, does it run on OpenMoko Freerunner? Does it run on iPhone, Purism, Librem 5, Nexus, Pixel? And have you tried Pipe4? So I have just combined the questions.
Yeah, so for the questions from the...
You can I can repeat the question if you want.
Yeah, so regarding supported hardware, it's basically when you can run a mainline kernel and do some OpenGL, then you should basically be able to run the stack. So once the compositor runs and the shell runs, then things should work. Hardware expectations aren't that dramatic, and if the modem is supported by Modem Manager with the different interfaces, then you should also be able to send SMS or do phone calls. So so it was definitely tested successfully on the Librem 5, obviously, which is the device I'm using. It was tested on the Pinephone. I think it should run without any major problems on a recent Raspberry Pi if you have a GSM modem attached. For the Samsung devices and others, it really depends on the mainline kernel support.
Oh, cool. So let's move on to the second question, which says, can your phone interact with the Econ or any similar framework in the Debian over a different machine?
So I'd say not at the moment, as far as I know. But you can basically just SSH into the device. So you have like quite some possibilities. But for Akonadi, like for the nice desktop integration where you plug in your phone and it kind of like gives you the context and other stuff right away, there's more work needed, obviously.
Okay. So the next question is about SMS and MMS. So it says, do you have a way to export and import your SMS and MMS into your regular Debian system?
Yeah, so there's two things to that, I think. One is you can basically run the same app on your desktop that you run on your phone. So you basically copy over the folder that has the things, and then you have the things available. And the other thing is it's in an SQLite database, the SMS, so you can also use export means there. And I think people also wrote export scripts already, but there's no tool in Debian at the moment that handles that.
So that's nice. So again, does your phone support making calls directly from the contact app? So anything about the contact app?
Yeah, so we have patches for GNOME contacts that do that. So you basically just bring up a contact and then call out. These are not in upstream GNOME yet, as far as I know. So that's one of the topics or one of the points I mentioned earlier, that we have patches that need to go upstream. And I think that's among them.
Okay, that's cool. So another question, I believe it merges with the hardware question, but I'll say, it says, does it support voice over LTE calls?
Not yet. There's no support, I think, on in Modem Manager for that at the moment, and that needs to be added.
So the next question is about eSIM, I believe. It's the same answer.
Yeah, so I read that. I have no idea how eSIM works, so I can't answer, sorry.
So we'll answer that a little later. So it says, can a regular Debian running device use the phone as a gateway to the LTE network to do call on Plasma GNOME app using send USSD commands from send messages and get PWS alerts?
Yeah,
so does it support?
So you can definitely do USSD with the device. So we're doing this for, like, I don't know, balance account, if you have a prepaid card to top up the balance and all these kind of things. But you can't currently do that directly from your laptop. So you basically would either SSH into the device or forward the session at the moment to do that.
Oh, that's cool. So another question says, will regular GNOME have an app to send and receive SMS calls natively and store them locally on the device?
So there is some talk what happens to Chatty. So if it's going to go to upstream GNOME or if it's going to stay outside, that's basically not totally decided yet. I hope that it kind of like gets moved to GNOME at some point.
So does the phone expose LTE 3G modem internal command set, for instance, so you can use SOCAT to send an SMS over /dev TTY XSX?
So you can access the AT commands on the device. So if you kind of like connect into it, then you can do that. But it doesn't kind of like forward the device again, like you connect it via USB to your laptop and the modem directly is not forwarded yet. There would be like some USB gadget support or something like that needed. And I just noticed that I didn't answer the PWS alerts question. So PWS alerts aren't supported yet either. I just had a look at that yesterday or the day before that. And there's some code missing in Modem Manager, but that's not terribly complicated. But it's still work that needs to be done.
Okay. So the next question with a wink says system MD or init.
Is systemd.
System. Yeah,
but since it's Debian, you can make it work with init as well. But we're currently using and testing systemd. But I can't currently see a reason why init wouldn't work.
Oh, that's cool. So are the battery charging firmware is open for the Debian access or is it a closed box?
I'm not. So there's no firmware in the battery charger. So at least on the Librem 5. So I think that doesn't look like a closed box.
Oh,
there is the USB-C controller. These usually do have firmware which interact with the charging, but the charging process itself isn't a closed box. You can regulate things. That's a chip which you can program.
So another hardware question, can it be used with NFC and contact tracking with the state run systems? Like it says in Corona tracking system, paying in the bus and stuff. So usual stuff.
Yeah, so that's NFC. So on the Librem 5, we don't have NFC support. I don't know about other devices for sure, but at least I don't know of any applications that do that at the moment. So that's missing as well.
So work in progress. So next is, are Kirigami KDE apps usable on Phosh?
It should be. There were people doing that. I've not run terribly much KDE stuff myself on the phone, but there were people running these, and it should be supported. So if it isn't supported, we should like work on integrating that.
Oh, that's cool. So there is another. It says, is OSK SDL keyboard for unlocking looks on boot in Pure OS? So it's given a link also if you like to check that out.
Oh, and no, it isn't. So I had to look at it, and we certainly want to work on the look support, but it's not there yet.
So then there is people thanking you for all the efforts on the Debian Mobile and the Librem 5, and there are many +1 with it.
Yeah, so, that makes me very happy.
So next we have a question from Perry from the IRC chat. It says, is it all interesting to support a non-phone device like N810? I would love to run a more recent Debian on mine with apps made for smaller screens, with a smiley.
Yeah, that should work. So as long as like you have a mainline Linux kernel, as I said, it works. That you might have like kind of like a modem quick setting, which is grayed out, but otherwise it detects if there's a modem. If there's no modem, it doesn't show anything in the top bar, so you can run without modem as well.
That's an interesting thing. Another question says, is there any cooperation or plan to cooperate with Google's Phosh, maybe running their kernel in favor of a Linux kernel?
Nothing that I would know of.
That was a quick answer. What about Android apps? Is there a plan to get them running here?
So I know that in the Mobian project, people were looking at Nbox for emulating Android apps. And I see that people might need some certain apps for the daily use. So this is actually something we want to care about. It's a little bit problematic. So I'd say if there is a web application, then you really want to use that one. So if it's like a web page that works, then that's probably the better choice, because you otherwise get into problems quickly with Google Play services on all these kind of things. So it's not just like emulating the app. You also need access to proprietary services. That's like a different field. So I'm concerned about the free software side, and I try to get around without these at the moment.
So that's all the question we have. Any last thoughts before parting?
No, thank you very much for your attention, and talk to you soon.
Yeah.
Thanks.
So thank you, Guido, for the talk, and Phil for the behind the camera direction. Good day.